Everybody, this is Mr. Brooks, and today I'm going to go over factoring using GCF. And when you factor using GCF, you can factor quadratics or polynomials. And I have this little chart about factoring, and there's a lot of different ways you can factor, but no matter what happens, when you factor anything, you want to ask yourself, is there a GCF? You want to try to factor out a GCF first. Again, no matter what. So always look to factor out the GCF, okay? The very first thing up top in the chart is, do the terms have factors in common? If yes, you can factor using GCF. And if no, then you go on to something else, okay? All right, so what's the greatest common factor? The greatest common factor is the largest number that both numbers have that are divisible by. So 12 and 6, both numbers are divisible by 6, and that's the largest. They're also divisible by 2, but you're looking for the greatest number. So 12 is divisible by 6, 6 is divisible by 6, 6 is the greatest common factor. And this is the way it's going to look right here. It's going to have an expression, and it's going to say factor this. And so you look at a GCF. So as we said, 12 and 6 have 6 as a GCF, and the way it's written is the GCF goes on the outside, and then you have parentheses. And when you have parentheses, on the inside of the parentheses, you're going to have the same number of terms as you have in the original expression. So you have 2 terms up here, you're going to have 2 on the bottom. If you have 3 terms in your original expression, you're going to have 3 inside the parentheses. GCF goes outside, parentheses. What goes on the inside? It's 6 times what equals 12x. Or you can think about it as 12x divided by 6 is what? But 6 times 2x is 12x. And 6 times what is 6? That's 1. Okay? So is there a check? The check is if you multiply it together, then you should have the original. So this is distribute. 6 times 2x is 12x, and 6 times 1 is 6. That's the check to know if you have factored it correctly, but it won't tell you if you have the greatest common factor. So you do have to kind of see if there's another common factor in here. If you have another common factor inside the parentheses, then you're going to need to find that greatest common factor. Okay, so just to review the terminology, factors are 2 numbers that multiply into a product. A product is the result of multiplying 2 factors together. If you have a number that only has itself and 1 as factors, that's called prime. So like 7 or 13 or 17, those are what come to mind. 23, you can't factor those except for 1 in itself. And so that would be prime. And there's really no point in factoring out a 1, right? So factors are 2 numbers that multiply together. And again, when you think about factoring, you need to think about multiplication. Okay, and then this is an important review. You're going to have to get to x to a power. And so what multiplied by what is x squared? If you're having trouble with this, it's x times x. Remember, x times x is x squared. And that's going to be key to know for how to handle some of these expressions, okay? And here's some examples. Factor the following expressions. So think about 8x squared minus x. We're going to have a greatest common factor. So what do they both have in common? Well, this is 1. So we're not going to have a coefficient, but they both have x. So I can pull out x as a GCF. And x times what is 8x squared? This is 8x. So x times 8x is 8x squared. And then this is minus 1. X times 1 is x. Right here, 18x squared minus 3. 18 and 3, the GCF is 3. And then 3 times what is 18? That would be 6x squared. And then this is minus now again. 3 times what is 3? It's 1. So that's how to do those. And then here's a little bit more complicated one. This is from level 2 of Delta Math. Negative 4x to the fourth and negative 8x. They both have negative 4 in common. If you have a negative in front, you want to factor that out because it's going to be easier for you to handle solving, and it's going to be easier for you to handle these factors if you get the negatives out. So anytime they're both negative, or I'm sorry, anytime the first one is negative, take out a negative 1 as a GCF, okay? All right, so I have x to the fourth and x to the third. So I know there's going to be an x, but how many can I pull out? It's always the smallest amount. So I can always pull out all these x's, and that's going to leave one more, but I'm going to pull out 3 from both. So then parentheses, negative 4x to the third times what is negative 4x to the fourth? That'd be x. And negative 4x to the third times what? Okay, so I need to get back to a negative, so this is going to be a positive. And this is the pattern. Whenever you pull out a negative GCF, it's going to mess with this sign right here, okay? So 4 times what is 8? That's 2. And then x to the third, so we've got all of our x's. So this is factored, okay? This is, again, negative in front, so negative 27 and 30. I would say that looks like 3. And they both have x, so I'm going to pull out. And that's the same rule, the smaller. See, the third is the smaller, and then this is just x is the smallest. This is 9. So negative 3x times 9 is negative 27. And then again, watch your sign. Negative 3x times 10. And I have 1, so x times what is x to the fourth? X to the third. Okay? And that is GCF right there. I want to clear this selection. Clear. There you go. Okay, why are we going to factor? So let's go into why we're going to factor. This is not a quadratic, but if I were to have you solve for this, I bet you could. And another way of saying solve for this is, where does the equation touch the x-axis? And it touches the x-axis. If you remember from this warm-up, your graph, where it touches the x-axis is the solutions. So another way of saying this is y equals 0. So, it touches, the graph touches the x-axis at where y equals 0. So you set it to y equals 0. So 10x plus 50 equals 0. And then if you solve for x, then you will have your solution. So minus 50 both sides, divide by 5, and you'll see that x equals negative 5. Okay? And you can solve that using inverse operations. Now, where does this touch the x-axis? So you can set y to 0 still. You want to set y to 0 still. But then it becomes where you can't undo it. So in the book, in the reading of the book, How Not to Be Wrong, it says it's no means clear how you're supposed to flip this equation around to solve for x. You can't use inverse operations to solve. I do know I'm supposed to set y to 0, but I don't know, I can't, square root the entire side because there's an x here, and I can't subtract 50x from both sides because it'll just put the x on the other side. So how am I going to solve this? Well, it turns out that I can rewrite this as factors, and it's the same thing. So here's our equation right here set to 0. Oh, I'm going to go back. I'm going to go back here. No, I'm going to stick with this. I'm sorry. Lose my train of thought. I'm going to factor this out and then set the factors to 0 because it'll be the same exact thing. Okay, so 6x squared plus 24x. The GCF is 6x. And on the inside is x plus 4. Okay, this is still equal to 0 because if I multiply this out, it's the same thing. So then if you think about it, what times, or 6x times what equals 0? 0, or x plus 4 times what equals 0. So both of these have to equal 0. So 6x equals 0 is a true statement, and x plus 4 equals 0. And all of a sudden, I have two linear equations that I can solve. X is equal to 0, and x is equal to -4. And because I factored this, I can solve it. I can't solve it any other way yet. We're going to talk about the quadratic equation, but the way you solve quadratics or polynomials is to factor them until you can solve those individual factors. Okay, so let's do one more. And in this case, you've got a GCF of 10x, and that becomes x plus 5 on the inside. That's equal to 0. Remember that this is a graph, and where the graph touches the x-axis is your answer, and it touches the x-axis at y equals 0. So in this case, x is equal to 0, and x is equal to -5. You'll see the pattern. -5 plus 5 is 0, and 10 times 0 is 0. And both of these have to equal 0 at the solution. Okay? All right, so that's it. Okay, so factor using GCF, and then if you want to solve, set each factor to 0 and solve that factor. All right, have a good one.